Hello everyone. Is my voice audible? Yes. So hello everyone. Myself Shrivardhan Gajanan Patel. Today in this video we are going to solve Get Computer Networks questions which is related to the Internet of Things IoT from 2018 and 17 with a detailed explanation so that you not only get the answers but you also understand the concept deeply. So let's start with the Gate 2018 question. So basically, this question tells us about a sequence of numbers which are 32 bits wide. Assume a transmission rate of 1 GB, Gbps means gigabit per second. So we need to calculate the minimum time before the sequence number wraps around. So basically, firstly understand what is the wrap around means. So wraparound means a TCP uses 32-bit sequence number. So the total number of space is 2 raised to 32, which can be uh, written in terms of bytes, as you can see in step one. So step two means it is about to send 4.29 billion bytes before repeating sequence numbers. Now the data rate is 1 Gbps equal to 10 raised to 9 bytes per second. So we need to convert that sequence bits into the bytes, which is equal to 34.32 into 10 raised to 9 bytes. So by dividing 1 minute, yes, sorry for the disturbance. So the calculated bandwidth will be converted into the bytes, and the time to wrap will be calculated as shown in the question answer, like step by step. And the step four will be the final step. We will round it to the nearest integer, which is 34. So the answer come is option B, which is 32, 34. Sorry. Next question. So the next question, it says that the match protocol failed with their sizes. So it means it had standard value. The UTP ports is 16 bit. The MAC address is 48 bit. IPv6 next header is 8 bits. TCP sequence number is 32. So as you all can see in the question, this is a fixed value and should be memorized. So the final mapping of this question would be as shown. I'll just show you the complete explanation. So the complete mapping would be P will be mapped with 4, Q will be mapped with first, R with second, and rest S with third. So the option is, yeah, as you can see. So moving towards the next question. So which statement about that, like I would not read the entire question, but I'll tell you the overall crux of this question. The question means which statement of TCP slower starts is correct. So basically, no, 1 second. Yeah, the slower start of TCP. So in the slow start, conjunction windows increases by 1 NSS per ACK. Since many ACK arrives in one RTT, the effective growth becomes exponential. So as you all can know, the exponential graph, it the RTT is when RTT and the growth is increasing exponentially. That means the windows doubly every RTT. Students often confuse there with the linear growth, but it's not a linear growth. Linear means happening linearly in the straight way, whereas uh, it's not a slow start. It's a fast start, right? So the final answer would be the only statement saying double each RTT is correct. So, which is option C, as you all can see. Next question. So, this question is been also came in GATE 2018, which tells us about what is the maximum distance between the two nodes for the cohesion uh, det detection. So, this question let me just explain you briefly step by step. The node must be detected cohesion without a carrier sensing time. So, considering the sensing time is 5 unit and signal speed will be around 10 meters per unit. So the complete distance would be 5 into 10, which is 50 meters. So the propagation delay must be less than the sensing time, which would be option A. Yes. So next question. So we are all done with the 2018 questions, which would appear in GATE exam, computer science and IT paper. So moving forward to 2017 questions, set one. So, 1 second. So now in this question, we have to state, does the client wait for the server FIM? So basically it means that TCP termination works in following steps. So first is the client sends FIN and enters FIN wait 1, receive ACK and move FIN wait 2, and then wait for the server FIN in this state. So by analyzing this and by seeing the options, we can already predict that the answer would be FIN wait 2, which is option D. Next question. 1 second. So now moving towards the next question. This is an scenario based question. So we need to tell that how a birthday is been attacked. Like a birthday attack is based on the finding cohesion on the hash function. Only an external attacks are exploit this. Senders and receivers cannot perform this uh, attack in a normal condition. So this condition has been performed by the attacker. So as you all can see, the step-by-step explanation, the S already holds a private key, can be directly signed a different message without a buddy attack. So I, which will be the first, is not necessary for the attack. So who would be the that responsible for the attack? So as a perspective of a third person, R is not a private key, not a generated a valid single what signature. Birthday attacks alone cannot be created signature. So third is also an impossible option. So we are remaining with an option only of second, which is C option. Yeah, it's an correct option. Moving towards the next question. Yes, so this question is a critical question. Like you need to firstly know about what is a polynomial, quadratic equation, and all that stuff. So now basically we are dealing with a cubic polynomial, cubic polynomial equation, which states that a given message and generate a polynomial and find a transmission message. So firstly, we need to convert that polynomial into a binary which becomes 1011. As you can see, the second step, we need to divide it by 1. We need to like XOR it, XOR it, right? The append 0 to the message based on the degree of polynomial. Perform module to division using XOR operation. So as you all can see in the steps, we need to perform the operations. The remainder obtained is 100. Then append this remainder to the original message. Append this means we need to add at the last. So the answer which is given is this, which is 010110111101, which is option C. Very good. Next. So 15th question, like 15th question on the basis of paper. So now, basically we have given a P and Q value in RSA and a public key is 35. So what would be the private key? So first calculate N as the product of P and Q. As you all can see in step 1, which is 221, that gives 221. Then calculate pi of N, which is 192, pi of 192, pi of N, which is 192. Now find the D such as 35 multiplied by D gives the remainder 1 which divides by 192. By checking the option, D is equal D equals 11 satisfies the condition. So by the options, we will determine that A is an option for D. So moving towards our last question of the day. So basically, this is a last question and the most critical question of all over the types. So basically, we need to find an efficient of stop and wait protocol. So basically, efficiency means data transmission time divided into total time. So the data time is 16 millisecond, as you all can see, it's given. Propagation delay is 1.5 millisecond. ASK transmission time is 0.16 milliseconds, sorry. Processing time is also being given as 0.25 millisecond. The total time becomes 17.91 millisecond. So here I have provided a step-by-step complete discussion about this question. So the efficiency becomes 16 divided by 17.91, which gives us approximately, by calculating the percentage, is 89.35. So, which is option C, which is option C, but here it is given option B. So, by calculating the value, you need to determine that which option is been correct and calculate it according to the uh, accuracy and the options provided to you. I'm talking about the GATE exam. I'm also preparing for a GATE exam, which is uh, like which is very not difficult, but you need to be consistent as well as you need to be attentive in the college as well as in the class that you join. And by learning online, you can also score a good score in GATE. But yeah, so that's all from this video. We have covered a GATE 2028, 2018 and 2017 computer network questions with a detailed explanation. If any help to you, make sure to like and subscribe and share this video to all of your friends. See you in the next video. Bye bye.